Hi students, in this video we're going to look at an introduction to rectangular hyperbolas. So after watching this video you should be able to recall the equation of a rectangular hyperbola. You should be able to understand how the dilation affects the shape of a parabola and also understand how the translation affects the location of a parabola. Right, key things to recall to be able to remember how to substitute into a formula. And also that numbers cannot be divided by 0, right? So that is, we call that undefined if you divide a number by 0. All right, so rectangular hyperbolas. So a rectangular hyperbola is a graph with the equation y equals a, which is just some number called the dilation, divided by x. So y equals a, some number, divided by x. Here in our diagram we've got our rectangular hyperbola here. It's got an equation y equals 1 divided by x. So notice it's curved and it sits neatly between these blue dashed lines and in opposite corners of in opposite quadrants there, vertically opposite quadrants. The main reason a can't equal 0 was if we have y equals 0 over x, that's just the same as saying y equals 0, which is just our flat line. It'll just be our flat line across here. So that's why a can't equal 0. We'll just get a horizontal line if a equals 0. So a can be any number apart from 0. All right, now the key thing about our hyperbolas is note that they never cross our x-axis or our y-axis. So they don't cross the lines x equals 0 and y equals 0. Now these lines, because our graph never crosses them, they have a special name, and they're called asymptotes. So an asymptote is a line that a curve approaches and gets very, very close to, but never touches. Okay, so that's like these blue dashed lines up here along our x-axis at up along our y-axis at x equals 0, and along our x-axis here at y equals 0. Now, with a bit of thinking, we can actually work out why these asymptotes are occurring. So let's consider, let's say if x equals 0, and use our formula y equals 1 over x. If we do that, then y is going to equal 1 over 0 if x equals 0. But that doesn't work. We can't divide by 0, right? That number is undefined. So what that means then is x cannot equal 0. And so hence we have that asymptote, that line at x equals 0, because we know our graph will never get close to that line, x equals 0. What if y equals 0? If y equals 0, we'll have 0 equals 1 over x. And if we rearrange this by multiplying both sides by x, x times 0 is going to be 0. Those will cancel, leaving 1. Well, that doesn't work either. Right? 0 can't equal 1. So that means the statement we've made at the start, y cannot equal 0. Right? That statement we made at the start must be wrong because we can't have 0 equaling 1. So our graph, our asymptote, says that we can't go across or can't get to this point where y equals 0. And so hence you see our red lines here get close to y equals 0 and get close to x equals 0, but they won't actually ever touch it. Now, our dilation, so that's our a value. If our a value is greater than 1, our graph moves further away from the asymptotes. So here for this purple graph, we've got a value of a equals 2. And notice we're moving further away from our asymptotes compared to 1 over x here. If our dilation is between 0 and 1, so if our dilation is getting smaller, like this black curve, it's got a dilation of 1/4, our graph moves closer to our asymptotes. So remember, dilation means stretch. So the greater our stretch, we're stretching it away from our axes. And if our dilation is less than 1, we're compressing it towards our asymptotes and towards funnily enough, this point in the middle of our asymptotes. So if A is large and positive, we're stretching it, and if A is smaller than 1, we're compressing it in between our asymptotes. Now, when dilation is negative, the hyperbola is flipped across the asymptotes. So we've got 1 over x here. If we change it to negative 1 over x, notice our branches flip quadrants. So instead of being in quadrants 1 and 3, for our branches, they've now flipped and they're in quadrants 2 and 4. So that's if our hyperbola is negative, it switches quadrants. All right, and then additionally, hyperbolas can also be translated. So in the equation y equals a over x minus h plus k, the graph has been moved h units to the right and k units upward. Notice that just like with all our transformations, whatever happens to x is the opposite of what we think. So we've got x minus h, which we think should move it to the left, but that minus sign actually means we're moving it in the positive direction. It's the opposite of what we think. This k value does work according to how we see it and our intuition, what we think it should say and how we think it should move. Now, note that originally, as we talked about, our asymptotes were at x equals 0 and y equals 0. Our graph could never cross those lines. So if we now shift them vertically, we're moving our graph up k. So that's our y value. So our asymptote then changes from y equals 0 to y equals k. And then if we're moving horizontally, h units, then our asymptote moves from 0 to x equals h instead. So these values, h and k, they tell us how far our graph is moving, but they also give us the equation of our asymptotes, which is quite important. All right, so for the hyperbola we've got here, 3 over x minus 8 minus 7, it has been translated. So let's do the x one first. We've got negative 8 in there, so it's the opposite to what we think. So because it's with our x term, so that means it hasn't moved 8 to the left, it hasn't moved 8 in the negative direction, it's moved 8 in the positive direction, so to the right. So we can say it's been translated 8 units right. And then negative 7, that one does move according to how it looks. So negative 7 means 7 units down. And it's been dilated by a factor of, the number at the top there is a 3, so it's been dilated by a factor of 3. Now it's asymptotes. So our first asymptote, or our y asymptote, is our k value, the back here. So its asymptotes now are y equals negative 7, which is down here. Y equals negative 7. Smack bang there at negative 7. And x equals, we've got negative 8 in our fraction, so switch the sign. It's now 8, which is this value here. X equals 8. And those are our asymptotes. Again, we can read them off straight from our formula. Alright, so after watching this video, you should be able to recall the equation of a rectangular hyperbola, understand how dilation affects shape, and how translation affects the location, especially looking at those asymptotes and how they change location.